back at AP Review. This is 2011 Form B, ABBC Free Response 1. This is one of those ones that you open the test book and realize that there's an awful lot of words, and you think, did I sign up for AP English or AP Calculus? But here we go. A cylindrical can of radius 10 millimeters is used to measure rainfall in Stormville. The can is initially empty, and rain enters the can during a 60-day period. The height of the water in the can is modeled by the function S, where S of t is measured in millimeters and t is measured in days from 0 to 60. The rate at which the height of the water is rising in the can be given by S prime of t, which we have right here, and which I'm going to put in as my y1, right? I'm going to be in function mode, so even though these are t's, I'm going to put these in as x's, right? Make sure you're in radian mode as well, right? Because boy, do you not want to take the AP test in degree mode. That would be an unfortunate thing. It's like meme-worthy. There are memes, I'm just saying. All right, cool. So I put that in right. All right. I also might as well, I don't know if I'm going to have to graph it or not, but I might as well change my window from 0 to 60 because I know realistically that I'm going to have x coordinates go by 60. I also know having a negative height doesn't make any sense. And I don't actually know the height of the can. I just know its radius. So I'm just going to give it a max height of like, I don't know. We'll say 100 millimeters for now. I don't know. It's probably way higher than that, but we'll start there. Okay. Cool. According to the model, what is the height of the water in the can at the end of the 60-day period? Okay, so if this is the rate, right, so first off, I'm going to note to myself that this is what I called y1, and I'm also going to note that this is the rate of change of the height, right? So S is height, S prime is the rate of change of the height. So in part A, right, I know that S of 0 is 0 because they said that the can initially is empty, and what they want is S of 60, right? So in order to find that, I'm going to use the first fundamental theorem of calculus, which says that if I integrate S prime of t dt from 0 to 60, I'm going to get S of 60, which is the thing I want, minus S of 0, which is just a 0 anyway, so here it doesn't matter. So essentially, I just need to integrate from 0 to 60 of S prime of t. So the AP needs to see that you do this, like you have to write this information, and they just want the approximate value, right? They just want S of 60 is approximately whatever. In order to type this in my calculator, I'm going to do function integrate, right, which is math 9, y1 with respect to x, because that's my t right now, from 0 to 60, right? So I go ahead and hit math 9, right? I go to vars and over to yvars, and I pick function and y1, comma, with respect to x from 0 to 60, right? Again, you want to get quick at typing stuff in your calculator, and I get that it's 171, so yeah, my original y that I set would not have been, it wasn't the millimeters anyway when I set my y value in my window. What was I thinking? It's the rate, and this would be millimeters, right? Cool. Make sure you have your units. Make sure you have your integrand with your limits, and make sure that you have your answer to 3 decimal places. Cool. Part B, according to the model, what is the average rate of change of the height of the water in the can over the 60-day period? Show the computations that lead to your answer. So there are actually 2 ways to do this. You could understand that if you want to find the average anything, right? Oh, I'm going to need this again for a sec, so I'm going to store this as alpha A. So there are 2 ways to do this. Option 1 is to recognize that the average value of anything is to integrate that thing and then divide by the width of the interval, which would mean integrate S prime to find the average rate of change and divide by the interval of 60, the width of 60. But there's an easier way to do that, which is to recognize that you already know what S of 60 is. So you could do one of 2 things. You could either be like, oh, I know the average value formula, right? The average value formula for pretty much anything, right? The average of any function over an interval is integrate the function over the interval and divide by the width of the interval, which is fine. And that's great. Or you could notice that you actually already did this in part A. You could realize that if you integrate S prime, you're going to get S of 60 minus S of 0 over 60, right? So either of those are fine. So if you take the thing that you got as your answer from part A and divide it by 60, then you're going to get the average value. So essentially, if I take the thing I just stored as A, which was the 171.81347 blah, 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 divide by 60, right? I'm going to get that is approximately 2.863 or 4 millimeters per day, right? Because it's the average rate, right? The average rate of change, so millimeters per day. All right, part C. Assuming no evaporation occurs, at what rate is the volume of the water of the can changing at time t equals 7 indicate units of measure? So this has now become a bit of a related rates problem. But the thing is, it's not a super hard related rates problem, right? So let's look at C. We're looking at a cylinder. We're looking at a cylinder where the radius is a constant 10 millimeters, right? They gave us that. And then you've got some cylindrical can, and then you have some height, h. But h is S of t, right? Like h changes with time. So if I want the volume of the water in the cylinder, right? Like this is the volume of the water. I need an equation. So here's what I know. I know that the equation for volume of a cylinder is the area of the base, like the area of that 1 CD, pi r squared, times the height. So it should be volume equals pi r squared times height. But r is 10 millimeters. It is a constant. Cylinders have a constant radius, and this is not changing. This is a cylindrical can. It's a fixed radius, right? Like I have my cheapo Aldi brand soda can here. That's a fixed width soda, right? Like that radius is fixed, right? I get that the can actually has like some slight bending and whatnot, but you get the gist. Okay, so really my volume is 100 pi times the height, which we know is actually S of t, right? That's the equation I want to use. So now, so when we do related rates, we use dread saw, right? Diagrams and rates, you label them. Equation, right? Derive with respect to time. Well, so my dv dt, or v prime of t, if that's what you like better, right, is going to be 100 pi, because that's just a coefficient, times s prime of t, right? Because that would be ds dt, right? So we want that at the moment when t is 7. So essentially, the answer I want is I want dv dt at the moment when t equals 7, well, that's just going to be a 100 pi times s prime of 7, which is something I can make my calculator do, right? My calculator can do that for me. There's a couple different ways to make my calculator do that for me. For me personally, I think the easiest option, right? So my calculator, I already have that in as y1. If I hit graph, and actually I'm gonna change my window and just go back to the y's being negative 10 to 10 because it's just the rate, and that's fine. Okay, so here's my graph, right? I want to know this rate at 7. So if you want an actual value on a graph at 7, you can just hit trace and hit x equals 7, right? Hit 7, and that'll give me a y value. So now that y value right there, that letter y, is s prime of 7, because this y1 was s prime, and I hit trace and hit 7. So I can do a couple things. I can either just use y, because if you note, that's like a 1.91, etc., right? If I just hit alpha y when I quit out of there, you'll see that it's that number. So since I only need it for this one instance, I could just use y. Or if you're afraid that you're going to need it later and you don't want to accidentally overwrite the y, you could hit stow and call it, let's say, alpha b, right? So either way, and then I'm going to times that thing by 100 pi, and I'm going to get 602.218, right? So I'm going to get that the answer is dv dt, right, or the rate of change of the volume, and you could use v prime. So you could either use v prime of 7, or you could use dv dt at t is 7, is approximately 602.218, right? And then units, it is a measurement of volume over time. So volume would be millimeters cubed over, it was days, right? So millimeters cubed per day. Now, do they ask you to interpret it? No, they just said indicate units of measure, which we did. So that's my answer. Part D. During the same 60-day period, on Monsoon Mountain, rain on Monsoon Mountain, accumulates in a can identical to the one in Stormville. The height of the water in the can on Monsoon Mountain is modeled by the function m, and then they give us an m, so let me erase all this stuff. I'm going to keep s, because I might need it, right? So s is the one in Stormville. So s, we have s prime, right? So now m of t is going to be 1 over 400 3t cubed minus 30t squared plus 330t. Cool. Okay. The height m of t is measured in millimeters, and t is still in days. Let d of t equal m prime of t minus s of t. Apply the intermediate value theorem to the function d on the interval from 0 to 60 to justify that there exists a time t in the window from 0 to 60 at which the heights of the water of the two cans changing, or the heights of the water in the two cans are changing at the same rate. Okay, so here's what the intermediate value theorem says. the intermediate value theorem says, like almost every theorem, that your function needs to be continuous, which both of these are, because this is a sine function with no weird division or anything. It's continuous, and my m of t function is a polynomial, and they're about as continuous as things get. So my functions are continuous. The intermediate value theorem says that for some value on the interval, so starting at the starting value usually of 0, your value is below a given quantity, and at the end of the interval at 60, your value is above 60 is above a given quantity. So what has to happen is between 0 and 60, you have to cross some given quantity that lives in the middle, right? So if, like, I'm trying to show that I have to cross, let's say, the x-axis, if I can show that at 0 my quantity starts below the x-axis, but at 60 my quantity ends above the x-axis, since a function's continuous by the intermediate value theorem, at some point in the middle, maybe multiple points, but at least once, to get from here to here in a continuous function, I had to cross the axis. You don't always start below and end above. Sometimes you start up here and you show that at 60 you end here, and that means that at least once you had to cross. Maybe you crossed here, maybe you crossed a bunch of times, but to get from here to here you had to cross. So that's all the intermediate value theorem says. So let's walk through this. So to show that the intermediate value theorem works, right, I have to point out that d of t, so S prime of t is continuous. M prime of t, which is a polynomial, is also continuous. So d of t, which is the subtraction of m prime minus s prime, is continuous, okay? That means I can use the mean value theorem. So what I need to show is I need to show that that d of t is less than 0 at one endpoint, and that d of t is greater than 0 at the other endpoint. So d of t is going to have to equal 0 in the window from endpoint to endpoint. Okay, that's the idea, right? And actually, it wouldn't be inclusive, right? Now, what that means is if d of t were 0, so I want to point out that if d of t were 0, that would mean that this thing has to equal this thing. So that's what they want us to show, right? Okay, so now let's actually walk through the math of showing that. I'm going to go ahead and put my m of t in as my y2. So remember, this was my y1. This is going to be my y2, right? It's up to you, actually. I might argue... Yeah, I mean, it's entirely up to you. So basically, here's what you have to do. You have to find d of 0 and you have to find d of 60, and one of them will be below 0 and one will be above. How you choose to do that is up to you. You might not want to, I don't know, it's up to you. You might not want to plug this stuff in. We'll figure it out. Okay, so d of 0, right? Like, you may not want to put this in your calculator. I think you probably do, at least for the 60, but we'll see. So, okay, so d of 0 is going to be m prime of 0, which we'll find in a sec, minus s of 0. So my argument is s prime of 0. You do want to put this in your calculator, and here's why. So when I go to put this guy in y2, right, that's going to be a 1 divided by 400. Sometimes I kind of cheat and rely on my math abilities a little too much and don't use my calculator as much as I should, and then I end up regretting it because it takes way more time, and it would have been faster to just lean on the calculator. So trying to be a better human and lean on my calculator a little bit more, you know. Welcome the robot overlords and whatnot. Okay, so, oops, I mean an x there. Okay, so double check that this is right. You get a 1 over 400, a 3x cubed, because that's an x instead of a t, minus a 30t squared, which is an x squared, plus a 330t. Cool. So in order to get this is going to be n derive y2 with respect to x at 0, right? And this guy is actually just going to be the value of this function when I plug in a 0, right? Which, if you can spot that that's a 1.5, that's great. It's not always going to be that easy, but in this case, like, it would be 2 times sine of 0, which is a 0, plus 1.5. So the way I would probably find this is I would probably hit trace. I would turn off my y2, right? I would trace my y1, I'd put in x is 0, and I'd get a y value. It's going to be 1.5, though. So if I hit graph and I hit trace 0, I'm going to get a 1.5. So this ends up being minus 1.5. I'm going to type this in my calculator, right? And when I do that, so I'm going to quit out of here and do math 8, right? Math 8. There's, I want to derive y2, comma, with respect to x at 0, right? And from that, I want to subtract a 1.5. So I do that, and I get that's approximately negative 0.674 or 5. So what I want you to notice is that that's less than 0. So what I'm looking to show is that when I find d of 60, it's above 0, and because this stuff's continuous, if I start below 0 and end above 0, I must have crossed 0. So d of 60 is going to be m prime of 60, which is going to be this same step, but with a 60 instead of a 0, minus s prime of 60, which is I'm still gonna do this trace thing, right, to find the y value, but now it'll be a little bit harder. So I'm gonna go ahead and hit trace, and I'm gonna hit 60, and I'm gonna get that this is a 3.4444 stuff, right? But notice that it's currently stored as my y, right? So this is a 3.447 blah, 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 but currently it is stored as y in my calculator, and I'm not going to give it any reason not to be stored as y as far as I know, but I'm going to store it, let's store it as c just in case, because again, your calculator will overwrite x's and y's. So if I quit out of this and I do alpha y, oh, that's L, sorry, alpha, my bad, alpha y, cool. I'm going to store that as alpha c, right? So what I want to do is this thing's the thing I called c, right? I'm going to go back up a couple times and hit that end derived that I had. I'm just going to do second insert and change that to a 60 and hit enter, right? And then subtract from that the thing I called alpha c, and I get that this is 69.377. So this d of 60 is a 69.377, which is greater than 0, right? So by the intermediate value theorem, so where we're going to jump back up to here, right, so based on this information, by the intermediate value theorem, d of t equals 0 in the window from 0 to 60, and that means that m prime of t minus s prime of t equals 0, which must mean that m prime of t equals s prime of t, which is what they wanted to see, okay? So that's the gist. Again, when they ask you about the intermediate value theorem, you're generally showing that at one of the endpoints the function is below a number. The number is often 0. It's very common that the number you're showing that your relationship to is 0. Every once in a while they'll give you a different intermediate value theorem where they say show that the function has to equal 22 in this interval. Well, then you'd be looking for one endpoint to be below 22 and one endpoint to be above 22, and then you can guarantee that you must cross 22. But it is disproportionately 0. The end.